everyone. Welcome to the second of our two videos on inverse functions. Hopefully you looked at the first video about graphs and tables first, because this gets a little more complicated, okay? Because we're trying to find the inverse functions of equations. So our goal for today is to take a look at, we're just do linear functions. We're going to take a look at this function right here, f of x equals 3x plus 4. And our goal is to create the inverse of this. So first off, if you're going to manipulate this function, this equation, f of x is always nice, but I'm going to replace it with a y. And you're going to see why we replace it with a y in a moment. It just gets a lot easier to deal with. So our goal for this is, you see y equals 3x plus 4, and right now we have y equals. Our goal is to have x by itself, and x equals. So what we're going to do is we need to get rid of this 3 and this 4. The first goal is to get rid of this plus 4. So I'm going to subtract 4 on both sides, because what happens is, on the right side, it just cancels out and goes away. And if you're wondering, well, Mr. Porter, how do I do y minus 4? My answer is, you don't. You leave it as y minus 4 on the left side, and that's equal to 3x. But we're not done yet, because we still have to deal with that 3, right? So I'm going to take what we have and divide it by 3, because right now it's 3 times x, right? And if I divide by 3, when I'm multiplying by 3, they cancel out. So on the right side, I'm just going to have an x left, right? And on the left side, once again, that looks like a hot mess, right? But you're not actually going to do anything with it. You're just going to leave it as y minus 4 over 3 equals x. Boom. We're actually did the hardest part of this whole thing. We now have x by itself. Now, do you guys remember the previous lesson where we talked about how like all the x's and y's get swapped? Well, guess what, guys? To find the inverse function, you see this rewritten thing right here? We're going to swap the x and the y. So now we have y by itself on the right side and x on the left side. And just to wrap it up, just to make things nice and neat, I'm going to replace that y with the f of x again. So now I have f of x equals x minus 4 over 3. Now, if you're ever wondering, did I do this right? Do I have an inverse function? Think about it this way. Look at what we started with right here. We multiplied by 3. Look at the x, sorry. Notice that the x gets multiplied by 3 first, and then we add a 4. Well, notice for the inverse, we have an x that gets subtracted by 4 first. The minus 4 is the opposite of plus 4, and it's happening first instead of second. And then instead of multiplying by 3 first, we're doing the opposite, divided by 3, and that's happening after we subtract by 4. So you have the inverse operations in the inverse function. And that's why we're always saying inverse, 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 inverse. It's the same thing. It's the opposite. Let's go ahead and do one more example, though. 2x minus 2, very similar. The strategy is going to be the same. I see an f of x. Just so I can manipulate things easier, the f of x is going to become a y. And now I'm going to solve for x. So to get x by itself, I'm going to add 2, because the opposite of subtracting by 2 is adding 2. So they're going to cancel out. And on the left side, we have y plus 2. That's not going to be 2y, guys. 2y would be 2 times y. So I'm just going to leave it as y plus 2. Now haven't solved for x yet completely yet. So I'm going to divide by 2. Because the whole point is 2x means 2 times x. And I'm going to divide and get rid of those 2's. On the left side, this whole thing that's happening, I'm just going to leave it as it is. So now we have y plus 2 over 2 equaling x by itself. Now remember, the whole reason we did this is so x is going to be by itself. Because now I can take the x and the y and swap it. So now it's y equals x plus 2 over 2. And the final thing we're going to do is replace y with f of x. And this is our inverse right here. And that's all it is for inverse equations, guys. If you have any questions, shoot me an email or stop by during office hours. Otherwise, you guys have a good day.